let's go ahead and get started then. Thank you for coming to my tutorial. Just so I have a sense of who I'm talking to, how many of you have ever done any work in the area of collaborative learning or have taken a course where you learned how to design activities for collaborative learning, or at least have taken a course where you have worked in collaborative groups? Okay, good. And how many of you have ever taken a course where you've learned anything about machine learning? Okay. And, okay. All right. How many of you would consider yourselves computer scientists? Okay. How many of you would consider yourselves people in education school? Okay. All right. I just wanted to get a sense. Great. Okay. So my name is Carolyn Rosé, and I'm a professor in the School of Computer Science at Carnegie Mellon University. And I work in two different departments. One is the Language Technologies Institute, where what we do is work on machine learning paired with language representations. And then my other department is the Human-Computer Interaction Institute, where we're very interested in how people interact with and through computers. And especially within that department, I'm in the Learning Sciences group, where what we're doing is developing computer-supported educational experiences. In my particular case, I'm very focused on supporting collaborative learning activities, and not surprisingly with the focus on the discussion, because that sort of brings both sides of my expertise together. Okay, so I'm going to focus today on trying to provide particular types of collaborative experiences to students using technology. And this includes things like projects and problem-based learning that might be projects that extend over an entire course for a whole semester, or they might be very short-term experiences that occur during one learning episode. And it might be about reflection on what students have already learned and discussing that with each other and comparing understandings, or it might be about working together to solve new problems. And sometimes apart from the formal curriculum of a course, or the content of what one hopes that students will learn during their experiences, we also focus on trying to provide a community experience around the learning so that students feel supported along their learning path, and they see that there are social resources that they can reach out to. And we're interested in all of these things. And what I want to talk about today is kind of some tools and resources, but also ways of thinking about how to approach the design and development of these kinds of experiences. Okay, so it's really important to realize that students often don't work so well together. So of the people who have ever taken a course in which you were expected to work collaboratively, how many of you were dissatisfied in some way with your team experience? Okay, yeah, I hear it all the time that students feel like, oh, I did all the work, or oh, I didn't get along with my teammates, or you know, so-and-so was, you know, just got on my nerves, something like that. Okay, so we need to have support, and support is often very effective in improving the experience that students have. And for decades in the field of computer-supported collaborative learning, in the work of many people, there has been design of kinds of support that mitigate the negative effects of just the fact that people are imperfect, and when we put them together, their imperfections make those experiences less effective than they could be. So we have been working on developing different kinds of environments in which students can work together in their learning, and they often have this kind of character where every student is sitting at their own computer. They have some visibility into some shared online space. So in this particular activity, there's a visual space that's shared where students can paste images, and they can see the images of all the students who are in there collaborative group, but there's also a chat where they're having a conversational exchange, and they can type their chat contributions, and then they become visible to the group. And in these environments where students, each of their own, we would say, client interface, are interacting with the group, we can also have a virtual agent, sort of a computer participant, who can interact in all of the ways in that environment that a human could. They could post images also to this shared visual space, and they can contribute chat contributions also to the discussion. And similarly, as students can view what's contributed by their partners, that agent also can see all of the contributions of all the students in the group. And so that gives the opportunity for those agents to monitor what's happening in real time in the interaction and to offer support. And that's one way that we can think of offering support and scaffolding for collaboration that's dynamic, that can respond to what's going on during a collaboration. Of course, there are lots of other kinds of static support for collaboration. You could even think that the design of what kinds of opportunities to contribute and in what form is a way of scaffolding the interaction by making it apparent what kinds of contributions are relevant to that activity. And these would be static forms of support that are persistent throughout the collaboration and that are given to all groups or all students, regardless of what's happening in a moment-to-moment basis. But in having a computer agent that's monitoring the behavior of what's happening in a group over time, then we're able to develop strategies that are actually sensitive to the context of what's going on. So in a foundational study, we measured the impact on a student's experience in a design activity. So this was in a sophomore thermodynamics course where students were working on designing a power plant using some concepts from that are from a particular area of thermodynamics called Rankine cycles. And we measured how much more students learned from this design activity if they had a partner student. How much more did they learn when they had the support of these designed computer agents? And if we put them together, were they even better? And what we found was that students gained about 1 letter grade of improvement from having a partner student to work with rather than working alone. And they also gained about a letter grade from having the support of an agent during this activity. But when we put them together, they gained about 1.25 or 1.24 letter grades of improvement. And so what we see there is that the kind of benefit that they're getting from their interaction with a fellow student and the kind of benefit that they're getting from the interaction with the agent are not redundant with one another. They're synergistic. They can gain more by putting them both together because they're gaining different things. From the carefully designed scaffolding, students get correct content. They get scaffolding on their reasoning processes. They get encouragement towards a productive end from the standpoint of what makes sense in the content. But from the other students, they gain other things. They gain thinking into another person's subjective view on the material, the fact that different people are approaching the problem in different ways, that there are trade-offs, and that working with people can also be, can intensify the thinking about the content. And so, so we see that putting these two things together, the fact that there are other students around that they can gain resources from, but also the scaffolding and the support for the learning activity, that we gain more from having access to both. So to make it dynamic, there's an underlying paradigm. And if you looked across the kinds of activities that we've developed and evaluated over the past decade or so, they would look very, very different from the top level view of what the students were actually doing and what the support looked like. But underneath it all, they follow a very consistent trend of analyzing the behavior as it's occurring over time, inserting interventions that impact especially the conversation that students are having, and that we have seen that despite the fact that they may look in very different ways, they have very consistent effects on how students learn. So today in this tutorial, I'm going to sort of talk about a progression of these issues. I'm going to start by talking at a high level about our development process and a little bit about tools and methodologies that we would like to be able to share with you. Then I'm going to kind of zoom in on the theoretical perspective and talk about what we have learned and what others have learned about collaboration and about discussion and about how people relate to each other can be applied to the design process, layered on top of this kind of general process overview that I will have already talked about. And then I'm going to show some particular corpus studies where we've gained some insights that we then applied in interventions. And then I'm going to talk a little bit more in detail about the actual techniques for language analysis that we use. And I'll end by talking a little bit more about the tools and resources that we offer. So our design cycle starts with data collected from classrooms. And it's important, well, they could be classrooms in the traditional physical sense, or they could just be places where learning is happening, and that could be formal learning or informal learning. And oftentimes the data that we're particularly interested in is conversational data. Here you can see a face-to-face discussion being facilitated, but of course it could also be online discussion. It might be facilitated. It might just be discussion happening in a discussion forum. But we're going to be collecting this data from a realistic context in which we expect or desire for some learning to happen. And then we have this data, and we'll store it in some computer processable form and model over that data in ways that allow us to draw some conclusions about what was important about the interactions that occurred, where they could be better, and how they might be better. And those findings motivate our design, which we then will deploy and evaluate in classroom contexts. And in some of the work that we've done, we've even looked to see how the broader classroom climate and relationships between instructors and students with one another are affected outside of the formal time when the activity that we're studying or evaluating has taken place. But that's not going to be a particular focus of my talk today. So from a technology standpoint, we have some tools to make it more efficient and possible to be able to engage in this iterative development process. Part of that has to do with some data infrastructure. So when we study conversation, it might be conversation that was originally recorded in speech. It could be chat conversation. It could be threaded discussion. It might be issue discussions in GitHub. It might be tweets on a Twitter stream. It could be blogs with comments. And these things look very different from one another. You can dump them, you can scrape them, and oftentimes the representation that you get is some form of XML, but it will be a different XML. It will have different kinds of noise. And so it's not trivial to put it into a form where we can apply some kind of machine learning model. There's a lot of cleanup and restructuring that needs to take place. And so something that we have developed that we offer as a resource that other researchers who want to be able to do this kind of work efficiently and broadly might benefit from is our work on what we are calling Discourse DB. It's an SQL database with a kind of schema that allows us to represent discourse in a kind of platform independent fashion, but also has some tools for actually helping to get the data into that form efficiently. Because built on top of that then, we have a lot of ongoing research in developing machine learning paradigms of different kinds. So we're just starting to do more work in the deep learning area. We were doing some work in probabilistic graphical models, but we also have some simpler just SVM type models that we've developed. and mostly supervised, some lightly supervised models that allow us to learn things about learning processes and what they look like and how people take up roles in their interactions. And we can use these then as lenses that help us to conclude things from our data. And when paired with our data infrastructure, then we're able to apply these analyses broadly across data that we're collecting in different contexts. And then we use these models as the foundation for interventions that can be context sensitive, like I have highlighted. And then, of course, more data is produced through these interventions, which, of course, then gets channeled back into our data infrastructure. So these tools that we have, which are largely open source and available for sharing, are ones that enable us to engage in this iterative process that I have mentioned. And what's important here is the idea that what we're building and what we're learning is from data. So it's very data driven, but you'll see the role of theory in sort of pushing us in a particular direction in our empiricism as I talk more about how that actually plays out. But here you can see a representation of Discourse DB. You can see that we have ways of representing kinds of properties of users that we want to keep in mind, that we can organize them into groups, or at least have data that indicates who is interacting with who and in what particular kinds of ways. And within a discourse or an ongoing space in which people are interacting, that can be divided into contributions, which are also organized in particular ways. And so our schema that we have, and I'm speaking at just a very high level now, I'm not going to get into all of the detail, but if you went to our GitHub repository, and I'm going to show you a pointer to that a little bit later in this talk, there's extensive documentation that not only talks about the entire schema, but also about the wide range of converters that we have for getting data from different sources into this kind of generalizable format. So in addition to Discourse DB itself, we have also hooked it up with some tools that allow for kinds of ways that people want to be able to engage with their data. In particular, we can export from Discourse DB into an annotation tool called BRAT. It's just one form of annotation tool that's already connected up to Discourse DB, but if you had a different annotation tool, it wouldn't be hard also to be able to customize that export and import process so that you could use a different annotation tool if that was more comfortable for you. But the idea is that if you have this data, you may already have a coding schema that you want to be able to apply to that data. There may not be existing models yet that can do that kind of application of that lens automatically, but you could use that annotation tool to annotate some of the data in Discourse DB, put it back in, and then we have also ways of hooking up tools, and in particular for supervised learning where we know what kind of labels we want to be able to assign to kinds of contributions. We have a tool bench called LightSide, also open source, that's also connected up to Discourse DB. So after you've annotated some data, you can extract it then in the format that can be input to the LightSide toolbench, and then go through the process of being able to build models to automate the application of those codes. Then you can use that. You can extract more data that hasn't been annotated yet from Discourse DB, apply the use LightSide models that you have trained to assign those labels, and then import them back into Discourse DB. So using this this set of tools, you can have collected your data from a variety of sources. You can do some annotation of some of it, then train models, and then apply those models to the rest of the data. And all of the infrastructure for being able to avoid having to write programs and to have to deal with messiness is sort of abstracted away. So where can you get these tools? You can go to our DANCE website, so dance.cs.cmu.edu. Actually, this is sort of the focal website for a community that we call DANCE that has a monthly online talk series and also a variety of other resources and discussion opportunities. And so we encourage, if you're interested in this, if today's tutorial tells you that you feel like you want to push forward on this, that you want to be able to make use of these kinds of tools, you can download them on the resources page. It will point you to our online repositories. All of our tools are, or at least a lot of them, are open source. And you're welcome also to participate more broadly in our community. Okay, so moving into the theoretical framing. And so how many of you were in the deep learning tutorial this morning, besides the one person who actually gave part of it? Because I was sitting there thinking while I was listening, and it was a very interesting tutorial, and I think it was an excellent introduction. But I think that my way of thinking about approaching machine learning, which I'm going to talk about a little bit in this segment of my talk, is just coming from a slightly different angle. And I think there are multiple ways that one can think about these things. And I actually think that the perspective as it was presented in that tutorial is much more consistent with how the bulk of the research community is thinking about deep learning and machine learning these days. But I just think that, maybe I'm just a renegade. But here's just, my view from my history in working at sort of the frontier between machine learning and the learning sciences. So let's just take an early example of machine learning applied to data in a learning context, and that would be automated essay scoring. Probably almost everybody has heard that since 1960, there have been fairly effective models for automatically at least assigning a grade to some written material from a student. And so at first this was a really exciting finding, and it's been applied. And it was the reason why big companies like ETS and Pearson and Kaplan started to really push into language analysis to be able to especially make it cheaper and faster to grade open-ended items on standardized exams. So interestingly, since the 1960s, the accuracy of these models, despite improvements in the state-of-the-art in machine learning and language technologies, has not substantially changed. The accuracy was already pretty good, even early on. But people were very skeptical of the models, the beginning models, because of the simple, low-level, not very meaningful nature of the features that were used. And now it touches upon issues from the second tutorial I sat in, the econometrics tutorial, where they talked about causality and the fact that there can be lots of features that seem to have high predicted value for an outcome measure, and nevertheless do not have any kind of causal connection. And similarly, teachers were very skeptical of the early models for automated essay scoring that focused on things like how many long words does this have, how long were the sentences, how complex was the syntax. And these are not really an indicator of good writing or good argumentation, but they correlate with those things. But the teachers still didn't like the fact that the grades were being assigned based on things that they wouldn't have valued, and they were skeptical that they wouldn't be misled in places where a student may have all these characteristics in their writing, but nevertheless it might be actually very bad writing. But also, it didn't provide actionable feedback. You can't tell a student you should use more long words or you should make your sentences more complicated. That's not going to help a student write better. And so what happened was there was a long time when work went into understanding more deeply what is it that teachers think of when they think of high quality writing. Or what do we actually know about the process of improvement in writing over time? What is it that we have learned from studies of student learning in writing contexts that tells us what we need to pay attention to in their writing and what feedback they need to have? And so since 1960 or so, there's been a huge amount of work, especially in places like ETS, Kaplan, Pearson, that are developing not only these automated assessments, but also systems that should be able to help people improve their writing. and they've improved. They have made models that are more valid, the teachers trust more, and also that move us towards being able to offer actionable feedback to students. And it's not because of better machine learning, it's because of features that were more valid, that were driven by theory and findings, and what other people outside of the automated analysis sphere were contributing. But then interestingly, it seems to have been forgotten, because in 2012 there was a big competition, a machine learning competition, and some people were invited, like the big players like ETS, and other people volunteered, and among them my student Elijah Mayfield, who was one of the early developers of the light side tool bench at a certain stage in its development. And in this competition, what they found was there was almost no difference in performance of this free and open tool bench, light side, and what had been being developed for decades from places like ETS. But actually, the problem was the formulation of the task, that they were only really looking at how accurate was the model at predicting the ideal sort of teacher assigned or expert assigned grades, and not whether the features were valid or whether they were useful for generating actionable insights. And so actually, whereas in the news it was a huge big deal that this free and open platform was just as good as these big players, but what made people angry was they were ignoring the whole history of this area of research. I think the take-home message here is that representation is really important. It's not just about predictive accuracy, but we need to have meaningful features, especially if what we want to do is offer feedback, especially if we want to understand what's going on, especially if we want to be able to say something about how collaboration actually works. So in that case, it's really important that we have some source that goes beyond just the low-level details of having a lot of data, but actually helps us to know what should we be looking at, where should we be looking in this data. So oftentimes when we are looking at computational papers where we have language discussion kind of data or any other process data, and we're trying to make a prediction, especially in machine learning and language technologies conferences where the goal is to develop a method, we tend to stop with looking at the pairing between data and patterns, and how did we get to these patterns, and the patterns themselves seem like they're important. But actually, when we think about applying these models to offer scaffolding and feedback to students, or to understand something about how collaboration works, we should think about a broader research context in which the data, where when you conceptualize the situation where the data is coming from, you want to understand that in terms of what is already known. And it's important to say to ourselves, okay, what does theory really mean anyway? Is there sort of a dichotomy between theory and empiricism? Actually not. Theories come from accumulating knowledge from empirical studies, that actually the theory builds in a lot of data from various sources that maybe if you consider all of the data that fed into the development of a theory, it might be more than the whole corpus that you have. It certainly encompasses much more richness than data from a single source. And so it would be a mistake to ignore all of the data that's behind the theory that helps us to understand, or the methodology that tells us how to apply constructs from that theory in formulating our questions and the models and the way that we would set up our prediction tasks. So what we want to be able to do is kind of zoom out, not to just focus on a set of data and making a prediction, but to think of it in light of what's known and how we formulated that experience from our understanding to begin with. So when we're thinking specifically about how are we analyzing social data and discussion data, which is probably the primary kind of data that we're really interested in analyzing in the research that I do, we're looking at these social processes, and there's a lot of work in psychology about what's happening during those social processes, and in particular from social psychology that describes what is it that people are trying to achieve in their social interactions, why might certain characteristics of those people interfere with them engaging actively or in certain ways, and what's happening in the exchange between people. And so if we can start out with an understanding of what those processes are and how they affect groups, how groups think of themselves, how groups are oriented towards one another, then we can start to look at how, layered on top of that understanding of what the processes are, we can think about how we can see some evidence of those processes in the way people talk. And if you look at writings from areas that are relevant to analysis of discourse, like sociolinguistics or discourse analysis of various forms, then sometimes even if you look at a study that's of a relatively small amount of data, but looking at it in a very deep kind of observational way, oftentimes in those analyses, reference will be made to how these processes, the same ones you would read about in papers from psychology, are being displayed through the choices that people make. And so then we can understand the characteristics of the language. What is it about the language we should be looking at that helps us to see what's happening socially? Like, so one of my PhD students, for example, is studying metaphor. Why do people choose to use a metaphor? How does that change how the experience of having exchanged some sharing of someone's personal experience comes across to somebody else or has an effect on their relationship because they made that language choice. And it may not be because of any individual words that they used, but the fact that they used a metaphor, or that they picked a metaphor that was related to some schema for thinking of the world, like characterizing a situation in medical terms versus social terms, for example, when we're talking about identity and how somebody is constructing where they stand. Of course, we could spend a lot of time talking about this, and we should kind of move on, but the idea really is that we can see when we start to think in terms of these processes that are invisible but that we know about from work in another field, it helps to raise questions about observations that we would make about the language. And once we kind of know what we want to be able to observe, it helps us to know how we want to try to approach the language data and to do our modeling. And if we build from our understanding of the invisible to the visible and to the models, then the models that we get, we hope, will be more effective for helping to shape these processes that are otherwise kind of occurring within a different sort of a realm. So we've been working for several years now on trying to identify some language processes that are useful at that sort of middle layer, that can be modeled with technology, but that are motivated by our understanding of what are the processes that are engaged when students are working together in a learning context. And you can read about that in a paper from 2013 from the most recent International Handbook of Collaborative Learning. And in that chapter on linguistic analysis of collaboration, we talk about this multidimensional framework that starts out with a core that captures the idea, the main idea of what we think is really most important about what happens when students work together in a collaborative learning setting, which is that they make their reasoning explicit and they listen to each other and build on each other's reasoning. But we'll also talk about how it is that the reasons why students may or may not engage in that process might be related to other processes happening that affect the positioning of students with respect to one another. So we want students to be close in a social way of thinking about the interaction. When they're in that close proximity, then they are more feel more safe, and they will engage more in these kinds of exchanges. So then you can see in other language processes how either a reflection of how students are positioning themselves or how students are working to move into a more appropriate positioning to be able to do that kind of exchange. So let's start with the core, which is an idea called transactivity. And this is going to come back again tomorrow, not tomorrow, but Friday, when I give my keynote talk. And so there's this idea of transactivity, which is a simple version of what I was just saying, that a transactive contribution is one where a student makes their reasoning explicit. And so that you see not just where they stand, but why do they take that stand. But you also see a connection with what's been shared previously within that interaction, usually by a different student. So here is an activity that has featured in several different studies my group has done, where students are working together on constructing a plan for a city about how it's going to use different energy sources. And here, one student is recommending nuclear energy and giving a reason for that stand. And a transactive response is as follows. Nuclear energy, as it is efficient, it's not sustainable. Also think of the disaster possibilities. So here a student is acknowledging the reasoning of the other student, but is explaining why they take a different stand. And in doing that, they're making their reasoning explicit, but and they're also relating it back to what another student has already shared. If it was non-transactive, they may nevertheless refer back by saying that they agree or disagree, but they may not show why, and so then it's not transactive. So a transactive contribution shows a great deal of trust and respect. And it also shows that a student is taking their own ideas seriously enough to scrutinize. So now you can see evidence that what they're doing is engaging in this process of improving their ideas together. And they have, so in order to do that, there has to be a certain social foundation that would facilitate that. So when we have looked across the very many different frameworks that have come out of the field of computer-supported collaborative learning for understanding from multiple dimensions how people are interacting, they almost always have a dimension that boils down to this transactivity dimension, where students are doing this kind of exchange, where reasoning is explicit and reasoning is connected from one student to the next. And they may call it something different, they may justify it under how it contributes towards learning in different ways, depending upon how they're conceptualizing that learning. But it seems almost universal that this kind of core is valued across frameworks. Now, if you think about the literature that justifies transactivity as a valuable learning process and explains how it is that it contributes, it draws from very different theoretical frameworks, sometimes cognitive and sometimes social, and brings those together. So from a cognitive perspective, we believe that transactivity is important because what it does is it indicates that a student is doing a kind of mental comparison. They're comparing across different mental models. That gives them the opportunity to identify gaps in their own understanding, which may lead to a cognitive conflict, which can be seen as a precursor to learning. And we can think of the whole thing purely from that cognitive perspective, but it's also true if you go back to the roots of transactivity that there are important social factors. And I'm going to, it's going to be important as you can continue to hear how this framework feeds into our design process to think about that pairing between the cognitive and the social. So actually the idea of transactivity grows out of a Piagetian view of learning. Work on transactivity started out actually in the early 1960s. And the idea here was that in Piaget's theory of learning, And I'm not necessarily saying you have to buy into Piaget's theory of learning if you value transactivity, but I think in thinking about how this idea has been developed over the years, you can get an idea of how it brings together these multiple different dimensions that are important. So in Piaget's work, he talked about how it is that students are more predisposed to learn and develop from an interaction if there's a balance between how they value what they currently know and the value that they place on the feedback that they're getting from the environment and their experience, what they're interacting with. It could be another person or it could be a thing, but if they come into it with this openness that there's something to be learned, but that they also want to reflect on what it is that they think that they already know, then that balance is something that's really important as a precursor to the experience of cognitive conflict, this idea that we've identified that there's a gap and now we're going to try to fill it. But later, in the 80s, Berkowitz and Gibbs, they were the ones who formalized this idea of transactivity. And whereas they've given you kind of a really simple view of how you might identify that a contribution is transactive, they actually had 18 different kinds of contributions that could be called transactive, that had different properties and that were appropriate in different situations. But they were all forms of what one might refer to as socio-cognitive conflict, which is sort of the representation that an interaction is providing the opportunity for somebody to experience a cognitive conflict because of the kind of social exchange that's going on. It's not that you can view directly a cognitive conflict, but you can view that the situation, the discussion situation, is providing an opportunity for that. And so you should see a correlation between these transactive contributions, which are forms of socio-cognitive conflict, and learning, because if what we are seeing is opportunities to experience cognitive conflict, if we see more opportunities, there should also be more cognitive conflict. So then if that's a precursor for learning, then we should also see more learning. So we should see a correlation. It shouldn't be like a 100% correlation because there are some nodes along the chain, but we should see a relationship there. And so, and in fact, we do see that relationship. It's continued to be developed in the later 1980s, where we saw that there was this idea of power balance on a social level within groups and how much of this socio-cognitive conflict we saw evidence of. And then later in other studies where there was an investigation of people who were friends versus people who were acquaintances. Would you see a difference in how much transactivity would occur within their interactions if all of the things were held equal? And would you then see that the difference in transactivity explained any kind of difference in learning? And in fact, we see in this 1993 study that there was more transactivity in friend groups than acquaintance groups, and on difficult concepts that additional transactivity predicted more learning. So if we see how these ideas are developing over time, building on one another, transactively as it were, we start to really see how the cognitive and the social are connected. We see that experiencing transactivity triggers or provides the opportunity for triggering of cognitive processes that are valuable for learning, but they may occur more frequently because of social factors. And so this pairing between social factors and cognitive factors means that if we can positively influence the relationship between students, that may have an effect on learning as mediated through this process variable. So this automatically gives us kind of a starting place in terms of thinking about these learning situations. And not just that we have to consider both social and cognitive factors, but what should we look for and enhance and support in the interaction that is related to those cognitive and social factors. And then how can we use that also in order to develop activities that have affordances that encourage the kinds of interactions that we think will be effective in that way. Just to kind of highlight that connection, I want to talk about a little experiment that was related to machine learning and language analysis, and how our thinking about the processes influences representations that we use for machine learning, and how that can aid in being able to do that effectively. And for doing this, I'll refer to two papers from my research team, one from a student who was working on a dynamic Bayes net model for measuring in audio data signals that represent something about the social context in which a conversation takes place. So we wanted to be able to measure what we're calling speech style accommodation. We know from sociolinguistics that we should see more speech style accommodation in groups where people have some respect for each other and are working to build common ground. If there are aspects of their speaking style that would set them at a social distance from one another, then they'll seek to suppress those differences in order to move themselves into a social positioning that's less adversarial. And so we should see that we are better able to measure speech style accommodation if we can identify those features that cluster together and indicate styles that are identity focused. But we should also be able to identify those sets of features as being suppressed in consistent ways over interactions if they represent something meaningful in an interaction, like a relationship between people. So if students come into an interaction, they notice their positioning, they want to work towards a more functional positioning, we should see a consistent motion over that interaction that suppresses those features that would set them apart. It should be consistent because they would engage in that suppression because they recognize that this is something that would set them apart, and so they, to the extent that that relationship is motivating any kind of shift, it should be consistent based on what they decided in the beginning, or how they sort of calibrated to what they noticed about the other student and how the other student was talking. Now, in this work, it was done. Do I have the picture here? Yes. What we did in this work was we started out with actually very basic low-level features. They were the features from the audio signal that are pretty consistently used in lots of speech work. There wasn't anything kind of fancy there. And you can see that over time, these O states, there are observations of just how someone's speech sounds. The important part of this dynamic Bayes net is the middle part, where we're representing our understanding of the social situation, or how these variables should be related to one another based on theoretical insights from generations of work in sociolinguistics, where the focus was on these basic social processes of how it is that sound and pronunciation is related to identity, and how that leads people to engage in processes of suppressing those in order to build common ground. That was represented in the network in terms of these accommodation states that sort of maintain this assumption that if what we're seeing is speech style accommodation for this reason, we should see a consistent motion of usage of these features over time. So I'm not going to get into all of the details of how this dynamic Bayes net worked, but there's a European Association for Computational Linguistics paper that describes how it is that this network was successfully able to measure speech style accommodation. Now, because we had this hypothesis about the connection between cognitive and social factors, we hypothesized that this one feature from an unsupervised model, unsupervised except for the insights built into the structure of the network from the theories that came from sociolinguistics, that one feature would significantly correlate with the prevalence of transactive contributions. So a different student with the same corpus, but now not looking at the audio at all, but only looking at transcriptions, of the discussion that weren't used in the first modeling part, went through and marked in the contributions all of those contributions that we would consider transactive based on the definition that we just discussed. And so for every interaction, then we would get a measure of the percentage of contributions that were transactive, that showed based on the structure of the reasoning that students that were listening to each other and building on each other's reasoning, which should be related to the social climate within the groups. So we hypothesized that just based on our theoretical model, this one feature that came from applying an unsupervised model to the audio data should predict this measure that comes only from the the text of the transcriptions. And we found that, in fact, there was this correlation with an R value of 0.4. So really not high enough that this could be our only source of prediction about prevalence of transactivity. It's not accurate enough to really trust. And yet it really says that this theory that came from generations of work from different fields, psychology, mostly in sociolinguistics, could be used to design features that would have some significant and substantial correlation with an outcome measure. And it's because these theories are driven by empiricism. They're based on broad observations from a rich set of contexts that would be absent in any individual corpus, no matter how big. And so using theory to motivate how we do our modeling and how we do our monitoring can be very valuable at focusing the model in terms of what it is that we have already learned from various fields over time. Okay, moving along then. So transactivity, it's the core of our multidimensional framework for looking at collaborative discussions. It's something that has a lot of support from prior work in other research groups as well as our own. And we have worked in a variety of contexts to be able to do computational modeling, to be able to do automated measures of transactivity. We've looked at it in different kinds of data sources and have had differing success. But a common theme is to build in insights about what it is that's going on at the cognitive and social level to motivate the representations. Now, if we respect this idea, the transactivity doesn't just come from nowhere, but it represents a pairing between what's happening cognitively and what's happening socially, then we should see that other kinds of language processes that, that show either movement or positioning in the social realm could be seen as supportive processes. And so we have looked at two different ones. One that's we see as being related to positioning horizontally or showing openness to other people's perspectives, and one that's more vertical that we would call authoritativeness. I'm going to talk about the horizontal one first. So here, what we're doing is we're looking at those aspects of language choices that show that somebody acknowledges that what they're saying might not be agreeable to the people who they're talking to. And in showing that they recognize this are also showing that they're allowing those other perspectives to have a voice. So a way that you can show that you're acknowledging that other people may have a different perspective and that that's welcome is by saying something, acknowledging that the other person might disagree, but attributing it to something outside of the interaction. So it might be something like, according to this thing that I read, this thing is true. Then it's not that we have a personal disagreement, but there's this source, and we need to consider that. It could also be that somebody just explicitly saying, from my perspective, it seems that something. And that allows another person to say, well, that's your perspective, but my perspective is different than that. But if you just say, it's this, it doesn't kind of acknowledge any kind of subjectivity. Or if you say, I feel extremely strongly about this, you're acknowledging that other people might disagree, but you're kind of not giving space for somebody else to openly disagree with you, because you're making it clear that you're just not really open to considering another view because you're committed to this particular view. So it's not a simple case of positive versus negative towards a particular position, but it's about acknowledging subjectivity and allowing other voices. Because you might say, I have substantial doubts about a particular perspective. Well, that is negative, but it's still open to considering that perspective, even though you've just said it's not your particular perspective. So sometimes people get confused between showing openness and being positive towards another view. You can show openness without being positive towards another view, but what we find is that actually just showing openness, regardless of whether you are showing it in a way that offers agreement or not, it opens up for other people to share. It increases, or it's at least correlated with increased prevalence of idea sharing. So we see this as an important supporting process for moving students into a social proximity where they engage in transactive behavior. We have tested this in an experimental study where we had a conversational computer agent where we could manipulate its style. And in one condition, it would state everything just plainly. This is the way it is. And in another condition, it was consistently using a style that showed openness. So from my perspective, it seems valuable to blah, blah, blah. So what we found was in the condition where the agent was framing things in a more open sort of way, students shared significantly more ideas. So it seems that not only do we have some correlational evidence that shows this as a supporting characteristic of the discourse, but we also see that if we manipulate it, we can actually have the effect of increasing the extent to which students are sharing their perspectives. So that's the horizontal dimension, but I'm going to talk a little bit more about the vertical dimension. And here I'm also going to talk about, again, how it is that we use our theoretical understanding to interpret the processes as we see them, and how that might lead to different decisions in terms of design. So the idea that we call measuring authoritativeness comes from the systemic functional linguistics framework of negotiation, that's what they call it. And it comes from sort of a water pipe analogy, where when we look at a discourse, we see these flows of information, and it's being attributed from a source, and it's being communicated towards a sink or a receiver. And so what you can do for each individual participant in a conversation is count how many of these flows they have participated in one way or another. And then you can look at how many of those was that student being attributed as the source. And so the proportion of their flows where they were the source, we can call their authoritativeness ratio. So as we look in collaborative interactions in pairs, as one student is taking up more the position of being the source, the other student is playing the other role. So in pairs, there's a strong correlation between the level of authoritativeness. In larger groups, it's less the case, but there are these strong correlations. But not everybody can be, extremely high on authoritativeness, because every time somebody is taking up that position as a source, somebody else has to be the recipient. What we find is that this has a strong correlation with self-efficacy. So students who are more confident that they are able to contribute meaningfully to the interaction usually take up more authoritative roles. And so because of how it places a student in a particular kind of position with respect to information exchange, it can also relate to how students learn. But we don't see a consistent relationship between authoritativeness and learning that would suggest that it's a causal connection. Instead, it seems to be playing a mediating role, and we'll talk about that a little bit. But first, I just want to describe the framework in a little bit more detail. So this visual representation helps to kind of understand the connection between what's happening on a turn-by-turn level in a discussion and how we get to this authoritativeness ratio. So the first thing to recognize is that there are two main kinds of flows in a conversation. It could be flow of knowledge, so we're talking, we're sharing information about something, but we could also be talking about or making a commitment to or reporting on actions that were taking place. Now, in the kind of collaborative learning settings where we've done the bulk of our work, most of what people are talking about has to do with exchange of knowledge, but it can also be exchange of action, and in particular in some informal learning settings like GitHub, where we see people engaging in gaining in their professional skills and mentoring one another through issue threads. Actually, a lot more of what's happening is about saying something needs to be done, saying that you did something, or saying that you're going to do something. There are two kinds of orientations towards the flow on the core moves, where the bulk of what's being communicated resides, and that is that you're either a primary or the source, or secondary or the sink. And so for knowledge, if you're requesting information, you're positioning yourself as the sink, and if you're responsible for communicating that information, then you're the source. And there's an analogous relationship with activity. It's important to note, though, that not every question places you in that recipient role, because you could be uttering a question in order to set up for yourself to be the source. So you could say, if you were a teacher, you could ask a question to a student. Let's say you're talking about ranking cycles, and you could say, is it really safe to keep increasing the maximum temperature of the cycle? And in this particular case, let's say a student says no, or even another student gives a reason why no, but when the teacher comes back in and says, that's correct, even though the student is the one who uttered the piece of knowledge and the teacher asked a question, we can see that actually the question was a setup for, and that the teacher was kind of fishing for something, and that ultimately the teacher is being positioned here as having the authority over that knowledge, that they're the one who gets to say what was correct or not. So even though they didn't actually utter that piece of information, they're still responsible for the flow. So it's important to note that actually this formulation of how information is flowing and who's the source is not really just a matter of the form of an individual term, but we have to think in terms of some sequences and how that relates to power dynamics within interactions. So again, and I'm probably not going to have time to talk about the computational work that we've done to be able to identify these codes, and then from them to be able to measure people's authoritativeness ratios, but it's really important to see these turns in their context. So we have to understand the significance of these turns, how it is that the form can be used in different ways depending upon where in the sequence those turns are, in order to be able to do that modeling appropriately. Okay, so once we have a way of measuring authoritativeness, what good does that do us? Well, we've seen in some, well, we've definitely seen consistently that self-efficacy is correlated with authoritativeness ratio. In some cases, it predicts learning. We also see that it predicts trust in doctor-patient interactions, and we have looked at it also in some other kinds of contexts. But now I want to talk to you about how it played out in a particular study of middle schoolers learning fraction, arithmetic, and pairs. because in this setting, we'll see that this authoritativeness ratio is one lens we could use to understand what was happening in an interaction, but there are other ways that we could have looked at it as well. And when we start to think about what makes sense about what explained learning in this context, we start to see again how it is that our theoretical understandings of the situation help us to build models and interpret our models more effectively. So in this particular case, we see an interface that's very much like what we had seen before, at least in terms of having one panel where there's some shared work going on. In this particular case, the middle schoolers were working on fraction arithmetic, and then there's the chat that's occurring on the side. And so in this particular study, we were working with 6th grade students. They were working in pairs, and each pair was competing with the other pairs for movie passes, and they really wanted these movie passes. Well, what were we studying here? We had 2 conditions. In both conditions, the students were doing these math problems together, and they had the chat to be able to talk about how they were working on these math problems. But we were experimenting with the different agent designs. So there was a computer agent in the chat. Every once in a while, that computer agent would lead the groups through a directed line of reasoning to engage them in concepts related to fraction arithmetic that would contribute towards their math problem solving. In one condition, it was a personalized agent. What we meant by personalization in this particular study was that in between problems and completely irrelevant to the math content, in the personalization condition, the agents would ask the students some personal questions. Let's see. Here's what that interaction looked like. So you can see there's no math content being exchanged here. So the agent would just ask one student something like, well, would you rather have a long flight or a long car ride? And the student answers, and then to the other student, do you like books or movies? And then they would pick one. And it was a different pair of questions between every math problem. And then the way the answers were used was to tailor the story problems. So that it's like this little game, irrelevant to the math, that the students in the experimental condition had. In the control condition, they just never had this personal exchange. So in both conditions, the agent would come and lead them through the math relevant part of the interaction. It was just these kind of irrelevant parts that affected the framing of the problem. So in the control condition where they didn't have these questions, the selection of books or movies or a car ride or whatever was made randomly. Okay, we expected that the students in the personalization condition would learn more. And we thought that the reason why they would learn more is because they would feel more connected to the agent, and so they would be more engaged in the math relevant discussions. Actually, there was no difference between conditions and how the students related to the computer agent, but what we saw was that that personalization affected how the students were interacting with each other. And so it affected the social environment, and you can imagine how, based on our discussions, we might see that as contributing towards the learning. We found that in the social condition, that experimental condition where we had those kind of irrelevant personalization interactions, students learned marginally more, even though there was no difference in terms of how they interacted with the computer agent when it was leading them through some discussions that were related to the math. So the question is, was this result even real? It was only statistically marginal. And if so, why would students learn more when those personalization discussions had nothing to do with the math? So what was going on? Well, interestingly, this data set was shared. And another research group took those discussions and noticed that actually there was a significant correlation between students engaging in insulting discussion behavior and how much those students learned. So students who insulted their fellow students learned more, and and there was this question, you know, is it better for learning that the people are rude to each other? Well, it would be hard to justify that being rude is important for one's learning. So what would be a more theoretically justified way of thinking about what was happening. So one way we looked at the conversations was to see how students were positioning themselves in these interactions from an authoritativeness standpoint. So we noticed that so in this correlational study where people noticed that the students who were rude to their partners, who we termed the bullies, learned more, they didn't notice that actually there was far more of this rude behavior in the control condition than the experimental condition. So in the control condition, the students who were rude to their partners learned more. It turned out that within every pair of students, not surprisingly, one student came in with more math knowledge and one student came in with less. That would happen just randomly. If they're not exactly the same, then one of them has to be more and one of them has to be less. And it was almost always the case that the student who was more belligerent towards their partner was the one who came in with more math knowledge. And what we noticed was actually the students in the control condition were more competitive for the movie passes. And so it was more often the case that the student who knew more about fractions was frustrated with their partner for not, being able to help them get those movie passes, and they would respond by being kind of rude to them. We saw much more of this rude behavior in the control condition than in the experimental condition, and also much more on the second day of the experiment than the first day of the experiment. So seeing more of it on the second day was universal. It would happen in the control and the personalized, but the difference was much bigger in the control condition, and especially on day 2. Because over time, students who were being competitive with one another got more and more frustrated with their partners because they thought they were losing the opportunity to get these movie passes. And you could see that in the discussion. But that doesn't tell us yet about learning. Why does this matter? So we started to look in terms of authoritativeness. How does this affect the exchange of information that was relevant to the task? And so we divided the students in the 2 conditions between the student who was kind of the bully, or which was almost always the student who was the more capable at math. And so in every interaction, there was at least one rude comment, or at least mildly so. So it was possible in both conditions to identify one student as the bully and one student as the sort of victim student. And we would divide them between conditions, and then we would measure their level of authoritativeness. And what we saw was that in the personalized condition, there was almost no difference in authoritativeness between the student who was the more capable student and the student who was the less capable student. The difference was bigger in the control condition. And this is on day 1. We can see it. And if we look at day 2, you can see this shift. There's this shift. So in the control condition, the difference in authoritativeness between the student who came in with more knowledge and the student who came in with less is much more pronounced, whereas there's no appreciable difference, although there is some, in the personalized condition. Nevertheless, actually, authoritativeness itself didn't directly predict learning in this study. But what it did show us was that on day 2 in the control condition, what happened was the students who were the less capable peers would abdicate the opportunity to contribute substantively to the problem solving to the other student who had been belligerent towards them, giving that other student the opportunity to take up more of an authoritative stance more often. But it wasn't just that they did it on average more, but that they did it specifically in those cases where they were grappling with some concept that they were less familiar with, where they actually needed more practice. And so what happened was that the student who was the bully scared them off, and when they would get to the place where they should really get practice, in the control condition, they would just abdicate to the other student. In the personalized condition, where they were staying at a more or less equal footing, when they would get to the same situation, the other student would give them help and they would try again, and they got practice at those skills that they needed. Now, if we look at the situation just from a cognitive perspective, we would see something that would make total sense, that students who got more practice at the skills that they didn't come in with learned more. And this would suggest that the intervention should encourage students to work harder at those skills that they don't know. But we already know that you need to practice skills that you don't know. But what is the reason why they're not getting that practice? If we only looked at it from a cognitive perspective, we would miss the fact that the reason why they weren't getting the practice was not because they were lazy or they just didn't know, but because of a social situation, that the competitiveness within those groups made it such that one student would scare another student away from getting that practice that they needed. And so what we really needed to do is break that tension, and we saw that the social manipulation, which was actually designed for a different purpose, actually had the effect of breaking the tension and creating an environment that felt safer to students to get the practice that they needed. Now, what's interesting here, it makes total sense. It links together the cognitive and the social. And it also shows us that the intervention that solves a problem, giving students the opportunity to practice at those skills that they need help on, might not actually look at all like, directly addressing that issue of giving them more practice on those skills, because this intervention had nothing to do with the math content and focused purely on the social dimension. But we know, because they're linked, that when we create this positive, trusting social environment, that students benefit also on the cognitive dimension, not because that social interaction directly affects how they're processing the information, but because it gives them a space in which they have the opportunity to get the experiences from a cognitive perspective that are valuable to them, to their learning. So in the end, we understand what was happening by thinking in terms of insights from prior work and theory from two different perspectives that help us to layer some structure on the data that we have. We didn't just say, okay, well, if we count number of belligerent comments, we can pick out the students that learned the least. They were not the students who were belligerent. The belligerent students, they're learning a lot more in the control condition. But essentially what's happening really is that in the control condition, the students who didn't come in with as much knowledge learn less than everybody else. And the reason is because in the control condition, those students were being scared off from getting the practice that they needed. So what we see is that there's a social problem that needs to be addressed. If we can address that social problem by some means that can be manipulated, apparently, because it wasn't the situation, through the conversation, we can address that problem. Okay, so that helps us to understand this idea that if we want to be able to look at this data that we're getting and make sense out of it to motivate our interventions, we have to understand what's going on at the psychological level from cognitive and social factors. Now, I can see that we're taking more time to go through all this than I kind of thought while I was putting these slides together. So let me just really quickly step through some studies of data from massive open online courses that also suggests some ways in which we might be able to enrich the experience of students in those contexts. So it's been a huge concern that in massive open online courses, students drop out relatively quickly. We have two different studies that I want to talk about, where we were looking at the discussion behavior, and we were looking to see what kind of indications do we have of what experiences students are having are associated with their increased commitment to the course or decreased commitment to the course. So one thing we looked at was evidence of cognitive engagement. Could we see that students in the discussion forum were either staying at a very surfacey level or digging down more deeply? And in the research that we've published, we've also talked about how we measured that in the language. I'm not going to talk about that in huge detail, but once we have extracted some of those indicators, we can use a kind of model called a survival model to be able to measure how it is that variation in what we observe about a student's behavior over time. In this particular case, it was about how much evidence of cognitive engagement and motivation do we see in the text of their contributions. How does that predict whether they're more or less likely to drop out by the next time point? This blue line over time, so this would be time, this would be probability of dropping out by the next time point. We see over time, people are more and more likely to have dropped out of the course. The blue line is sort of average for the whole course, and this red dotted line is how that probability curve is adjusted based on seeing a standard deviation more evidence of cognitive engagement and motivation, and this green dotted line is kind of an adjustment for seeing a standard deviation less. So you can see that when we see less evidence of cognitive engagement and motivation, students are much more likely to drop out by the next time point, and they're much less likely to drop out by the next time point when we see those pieces of evidence. We have done this analysis over 3 different courses, and we see consistently the same pattern. Similarly, we looked at signs of confusion and how people's confusion is being addressed through the discussion forums. So again, we're using machine learning to be able to measure confusion in how students and what students are saying in the discussion forums. And I'm not going to talk in great detail about how we did that measurement, but what we found was, these are just some of the features that we used, but again, over multiple courses, we see that when students express their confusion, they're more likely to drop out of a course, but if an experience occurs in the discussion forum that would address their confusion, that partly mitigates the effect. Again, we can do these kinds of assessments using survival models. And putting these results together that we've seen over multiple massive open online courses, it gives us some evidence that seeing students engaging in reasoning and exchange in the discussion forums is good. Expressing their confusion and getting help is good. Expressing confusion and not getting help is not good. We could hypothesize that if we offer students more opportunities to engage in that kind of intellectual exchange and also to get help to talk to somebody about the things they're confused about, to actually have somebody listen and respond to them would be positive. And so in order to test that out and to think about how it is that these findings from corpus studies might motivate us to develop some interventions that we could deploy in massive open online courses, we developed these chat-based reflection activities that could be situated in courses, and we've tested them in 3 different massive open online courses. And I'm going to talk in particular about the third one, medicinal chemistry class. In this particular course, it was structured more or less like a very typical MOOC with units of material that involved lots of videos and an instructor who was very committed to his class. And at the end of each of these units, there was an optional reflection activity that students could engage in. And the way we did this was that when students would get through all the materials for individual learning, at the end of the unit, they were told that there was the option of engaging in a reflection activity, and they would click a button to enter that activity. So students could skip it if they wanted to. There weren't points being assigned to students for doing it. A lot of students just skipped it because it wasn't required. But if students clicked to enter the activity, there may or may not have been another student there. So that would be a natural experiment. If you were in the econometrics tutorial, you heard about natural experiments and how it is that these natural experiments, even in secondary data, can be used as a way of approximating or at least suggesting that there might be some causal relationship there. So in this data, you can look at this flow chart as representing what might have happened at each time point, where a time point is kind of a week of activity where a student was engaged in a particular unit of the course. And in that week, they may or may not have clicked to enter that discussion activity. If they did, there may or may not have been a partner present to do it with. What we found was that the students who clicked to enter the activity and there was another student there for them to do the reflection with experienced a 70% reduction in probability of dropout by the next time point. If they clicked and there was no partner present, then their probability of dropout by the next time point was exactly the same as those students who didn't click. What that indicates is that it isn't the case, for example, that students who clicked to enter that reflection activity were just less likely to drop out to begin with. Because if they were, then we would have seen a difference between this first blue box, which is, that they didn't click at all, or the second blue box where they clicked, but they did the activity by themselves. It's only when they click to do the activity and there's another student there that we see the impact. And so what that shows is that there's something in that discussion that we provided that was motivated by our earlier correlational analyses. And we see here some evidence that motivation to design the activity, to engage them in the behaviors that we saw were associated with commitment to the course, actually were associated with increased commitment to the course. A big problem is that a lot of students don't click if it's not required, and even if they do, and even if it is a massive open online course, the fact of the matter is that even with 20,000 students enrolled in a course, at any given time when one student gets to the part of the curriculum where they're going to click on that button, it's very unlikely that there's another student at that point that's also clicking someplace else in the world. And so what we want to be able to do now actually is increase the likelihood that when somebody clicks, there's another student there to talk to them. So we're working on that. Okay, so very briefly, a lot of the work that I have talked about today involved substantially digging into the conversational data to be able to layer in a lot of theoretical understanding that comes to us from various sorts, and to automate then analysis in real time to use to trigger these conversational interventions. I was going to spend some time talking a little bit about our theory of language analysis, but I think that we've actually talked about it along the way. But I would say that we sort of stand in contrast to the view that we really want to build a fancy model that does everything and that kind of does the work for us. We're more interested in a process that allows us to take our theoretical insights and use those to motivate how we're structuring the data. And from those structures, then we're happy to use the computational tools to take them even further, to build more complex representations on top of a foundation that's already well motivated. But it's important to us to have that motivation going in. Now, we'd like to offer as kind of a way of getting into this kind of process for applying machine learning to language, our light side tool bench, not because it offers any tools that are magic or better than any other kind of machine learning, but because it has built into it a process that allows you first to design a representation, but then also to troubleshoot it and to try to identify places where it's not actually capturing the insights that that you want. I was going to make an analogy between machine learning and fiber arts. I have many hobbies in this space. And the one thing I will say about it is oftentimes we think of modeling in machine learning just in terms of the algorithms. But if you really think about what it takes to get from a sheep to a finished product, there's a lot of stages in between that actually have a huge influence on how nice the final product is. And so that's why it's so important not to forget about the important process of feature representation and to think about how that can be iterative. And this iterative process is very much built into this tool bench. And so I encourage you, if you're interested, to download it, read the user's manual, and start to play around with it. But we also have a computational linguistics journal article that came out sort of defining the field of computational sociolinguistics. And in that article, we talk a lot about how to think about language and how the fields of the social sciences, as they touch upon language analysis, actually speak to and listen to the area of machine learning, and what are streams of research in language technologies within that space. And so for many, many pointers into the literature, I recommend this article. But finally, I just want to remind you again about the dance community and how you can get access to our open source tools from that space, and also in that space find out about our monthly online talk series. So we've got tools that can be plugged into the Open edX platform. You can get our Lightside tool bench. You can get some code for social recommendation that can be used to introduce interventions into discussion forums. There's also a tool bench up there for building conversational agents. All these things are open source. They have GitHub repositories. The links are on the resources page. So I encourage you to take advantage of that. And thank you so much for joining me for this tutorial. Yes?
I've got two questions. So in your work, you have incorporated knowledge from a variety of sources: psychology, linguistics, sociology even. So how difficult was it to encode all this knowledge into the models? Was there any knowledge that you found to be impossible to encode?
Oh, I think I would say it's not that there's a kind of knowledge that's impossible to encode, but that you can't encode all of it because it becomes too complex. That actually modeling is always a process of data reduction. And so you always are losing something in formulating the data in a tabular form where you can apply any kind of modeling to it. So the question is, what can you afford to throw away? A lot of work in the social sciences broadly is very rich and digs very deeply into intricacies of how language or other kinds of human behavior works. And any subset of those observations can be encoded in some formal way, but it would be impossible to encode all of them all together. And so, because then you have no basis for generalizing. You have to be able to say, some things I'm going to have to let go of so that I can identify a pattern, so that I don't see every interaction or every contribution as being unique. And so, so it's really more of thinking about what makes sense to let go of. And that's why it's so important to understand these things from the broad theoretical perspective that allows you to say, in this situation, the question I'm asking makes certain aspects of what's happening more relevant based on what people have already found. And so that insight is going to guide me towards what data I need to have and what data I feel like I can let go of. Other questions?
So you looked in your experiments at two sides, kind of how the way people interact with each other, what they bring, their style, communication style, how that affects learning, as well as how the environment that you created for this interaction affects the learning outcomes. So I'm just curious, kind of from the prescriptive side, you know, how would you advise? You know, I don't think you can say one is more important than other, but how would you kind of advise the practitioners? Is it important to ahead of time kind of teach students how they should be interacting, or is it more on the side of the creators of the environment to kind of make those type of conversations emerge? How should we be thinking about it?
I think that's an excellent question, and I think you'll be frustrated with my answer because I think there's not one right answer. I think there's active research on all of these levels. So there's research on how to train people for collaboration, research on how do you find who should collaborate with who so that you can avoid some problems just in how you match students. And then there's how do you create an environment that sets students up to interact in productive ways. Even how do you pick out what the task is, not even the environment, but just even the task to make it conducive to productive collaboration, but then what kind of support do you offer along the way? All of these are active areas. I don't think that there's any consensus on what's more valuable. It might depend upon who the students are, or how old are they, at what level of collaborative skill, what are the demands you're placing on them. So yeah, unfortunately, I kind of can't answer that question. I would say what my advice would be to think about all of the ways that proactively to set up groups for success, to address it on all levels and not only focus on one. I think the one that I've done the least of is actually training people for collaboration. But I have seen, especially in really challenging forms of collaboration like capstone courses that are very consequential, that go on for a long period of time, where it's bound to happen in virtually every group that there's some substantial breakdown. In those cases, training seems to be really necessary. It also seems to be really insufficient because at the time when the breakdown occurs, the students are still going to come crying to their professor's door. However, it's useful to be able to point back to that experience. So that would be more of the scaffolding, the just-in-time scaffolding, but synergizing with the training that was offered. So I think all of these ways of encouraging productive interactions are important, and to use as many of them as possible, I think, is good, especially within the more challenging forms of collaboration. Other questions? Okay, yes, one more question.
Yeah, so what are you trying to do with deep learning?
Oh, okay. Well, we have actually been developing a deep learning approach to transactivity detection. And what we're doing is we're working on using a pre-training task from that we have a huge corpus for. And in our particular case, it was valuable to make use of entailment detection as a pre-training task, because it allows the models to learn abstractions of ideas and how they're related to each other, which you can imagine, based on my discussion of transactivity, is an important component. And also one of the big reasons why in the past models for transactivity detection didn't generalize well across domains. In our recent work, where we've used entailment as a pre-training task, and then had a small amount of data that was actually coded for transactivity, and then we adapted the model to that task, we were able to not only get high performance in the domain that we trained on, but it transferred across domains. We're still pushing on that, but that's our most recent approach. And now we want to also expand. And there has been other work in deep learning applied to discourse relation detection in general. And so we're sort of pushing on, in general, looking at a range of kinds of relations between spans of text and how we can use deep learning to be able to detect those. Okay, we're sort of over time for the tea break, but this was a great discussion. Thank you for coming, and I'm happy to talk further with anybody.